All right, so we're going to go ahead and get started. Today we're going to be doing CR 16, and we're going to start 4.6. Then we're not going to continue that till next week. Just a reminder for those of you that are watching this during the summer of 2022, there is no class on this coming Monday, July 4th. So no lecture on July 4th. So when we come back on Tuesday, we will do the rest of 4.6 and also 4.7. Now also for next week, so Monday there's no class. Tuesday there is the 4.6 and 4.7 we'll do. Wednesday is going to be our review, and so a week from today, next Thursday, it's going to be the exam, and so we'll be doing a review day, going through the sample test like we did last time, and then next week, Thursday, the day of the test, there's not going to be a lecture, assuming, of course, that Zoom works the way it's supposed to. So next week, we basically just have 2 days of live lecture just on Tuesday and Wednesday of next week. So we're going to go ahead and jump into CR 16 here. So this is a little bit review. So this is another one of these co-requisite review sections, but we do need this in order to do 4.6. That's why we're going to go ahead and review this. So some of this is going to be review for some of you watching. Some of you may not have seen this for a while, so we're just going to kind of do this to get everybody all on the same page here when it comes to this. So first thing we're going to talk about is the quotient property for exponents. If you're dividing two things with the same base, you're going to subtract the exponents. That's what we're actually going to be doing on these first couple problems here. So for something like this, for instance, you're just going to take the way the formula works is you have the base, which is 11, and you raise it, and so if we have something that's being divided, we're going to subtract the exponents. So really we have this right here. So it's 11 raised to the 6 minus 4, which is the same thing as 11 squared, which that's the same thing as 11 times 11, and that's 121. Okay, so that's all you have to do on that is just subtract them and then compute it. You can do the same thing with variables. Okay, so we got this one. We're just going to take the W, and we have 21 minus 6. So you're just subtracting the exponents here, and then that's going to leave us with W to the 15th power. There's nothing to compute here. You just leave your answer as the W to the 15th. This next one here, we're going to have to first, we want to divide the 64 divided by 8, and that is 8. And then we have x to the 9 minus 3, top power minus the bottom one, and you get 8x to the 6th power. And then that's it. There's nothing more that we can do with that one. So we just divided 64 divided by 8 is 8. We did that first, and then we did the exponents. If you have two exponents, you're kind of doing the same thing. 40 divided by 8 is 5. And then we have this here. It's the 2, and on the x there's a power of a 1. So we have 2 minus 1 there. We have y to the 6 minus 1, because there's a 1 on the y exponent as well. Then if you simplify that, you get x to the first 2 minus 1 is just x, like that. And you have y to the 5th power. And then that's as far as we can go on that. We have a you try it problem on this. So we'll just do this together. 100 divided by 5 is 20. And then we have x to the 15 minus 11. And we get 20x to the 4th power. And that would be your answer on that. So 20x to the 4th. And we'll do one more of these kind of problems. We're going to divide this first. So 80 divided by 16 is 5. Then we have x to the 7 minus 5. And then we have this here. The y's are going to actually, you could actually just cancel the y's out altogether. But if you wanted to see how that's done with the exponent, here, it's going to look like this. So 5 to the x raised to the 7 minus 5, and y to the 0 is what you're going to get. X squared y to the 0. And then y to the 0, this part right here, anything raised to the power of 0 is equal to 1, which means that we can just drop the y altogether and just write it as 5x squared. So the y's, again, you can just drop those out, cancel them out if you wanted to, and then proceed. But either way, you're going to get 5x squared. Okay, now continuing on, we're going to be doing these kind of problems here. So these are other ones that are in this section. Now for these, the best way to do these kind of problem is to take everything on top and divide it by whatever you have on the bottom. So I'm going to do 8x cubed divided by x minus 5x squared divided by x plus x divided by x. So because there's only one thing on the bottom, we are allowed to do that. So everything on top gets divided by the x. So here we have 8, and then you don't have to show the work for that. You can just go ahead and subtract it. So 3 minus 1 is going to be x squared. And we have a 5. And then this one, you have subtract these exponents. 2 minus 1 will just give you an x. And the n here, this is not a common mistake here would be just to cancel all this out and then have nothing. But remember that there's really a 1 that comes in front of each of these. So if you divide out the x's, get rid of those, there's still going to be a 1 left over. So don't forget about that. If you don't just cancel it, make it a 0. You want to make sure you put the plus 1 on the end. All right, so next one, we're going to do exactly the same thing. Even though there's a 4 down there, it's still considered one term. So we're still able to separate this and divide all of them by 4x squared. Just like that. So everything on top is divided individually by 4x squared. So now we're going to reduce each of these terms separately. 8 divided by 4 is 2. Then we can subtract the exponents. 5 minus 2 is a 3. 16 divided by 4 is 4. And then we subtract the exponents. 4 minus 2 is a 2. 12 divided by 4 is 3. The x squares, we can just cancel those out altogether. So we can just leave this as plus 3. Again, that would be x to the 0 if you were to subtract those, but then that turns into a 1 anyway. So we can just not write that and just put plus 3 on the end. So now we just have some higher powers here, but doesn't matter. We can still do exactly the same steps as before. All this is the same. Now, what's going to happen on this that's going to be different is we're going to get a negative exponent here if you when we do these second parts. So this one, the x cubes are going to cancel, and you're just going to get an 8. But this, we're going to get a minus x to the negative 1 because we have 2 minus 3. Okay. Now this one in the end like this, I'm actually just going to leave it as 3 over x cubed. There's not really anything we could do that. We don't want to make it a negative exponent. Typically, they want you to write this with positive exponents. And so to do that, if you want to make something positive, then what you do is you just put it on the bottom of the division bar there. So we just, if we drop this down below, that's x to the power of a positive 1. And I'll just leave this the way it is. And so then this is our answer that we have. So you want to write this, typically they have you do it, write it with positive exponents. And so that's why they have you do that. So that's all you're going to do on that one. So we have another problem, a you try it problem. So let's go ahead and we'll go through this together. 9x to the 7th over x squared. 7x to the 4th over x squared. And then x squared over x squared. This, if we subtract these, 7 minus 2 is x to the 5th. I have minus 7x, and then 4 minus 2 is 2. And I have another x squared over x squared. Again, there's ones in front of each of these. And so that would just be a plus 1. And that would be it. That would be your answer. All right, so one more of those, and then we'll start getting into long division. All right, so this one is going to be done the same as we had before. So let's go ahead and take a look at that. All right, so with this, go ahead and write this out. Everything on top, we're going to divide by x to the 5th. So we'll just do that for each one. Okay, and now we want to simplify that. Okay, now the one on the end, we're not going to do anything with, because it already is a positive exponent. So I don't want to change that at all. But what I can do is the x to the 5ths are going to cancel out. I get 2. 6 minus 5 is x to the 1, x to the 1st power, and then I'm just going to leave this alone just as that. All right. So now that we have that complete, we're going to move on now to talking about long division. Now for long division, what I'm going to do is write out this. I'm going to do a numerical example first. Okay, so let's suppose we want to do, again, we want to do 178 divided by 3. Okay, so we want to do 178 divided by 3. The first number goes inside the division bar, and the 3 goes on the outside. Okay, so we have that. Then what we would do with long division, just to review that, is if 3 goes into 17, 5 is the most you could do there, and that would be 15. We're going to subtract. We get a 2, bring down the 8, and 3 goes into 28 9 times, with 1 left over. So this down here is called the remainder. This number outside is called the divisor, and this number is called the quotient. Okay, so we have all of those. So that would be what normal long division looks like. It's something that you may have seen before in the past. We're actually going to do the same thing, except we're going to be talking about working with the algebra on that instead. So before, we had the first thing was what goes inside the division bar. So we're going to do the same thing here. The second thing that's going to go on the outside, x plus 5. And then inside the division bar, we have 2x squared plus 3x minus 35. Now, what you might be asking is, well, can I just divide like I did the problems before? If this is the same thing as 2x squared plus 3x minus 35 divided by x plus 5 is really what this problem is saying. So you might be thinking, well, can I just take 2x squared divided by x plus 5, 3x divided by x plus 5, and minus 35 divided by x plus 5 the same way we did all those other problems before? And the answer, unfortunately, is no. And that's because we now have 2 things that we're dividing by. If you have a sum or a difference here, a plus or a minus, unfortunately, we can't do the same process that we did for those previous problems where it was just one term. You could take everything and just divide by that one single term. Now we have 2 terms down here. So whenever you have more than one term, unfortunately, we can't do that. We have to resort to using a long division techniques that we're using here. Okay, now the way that we're going to do this, if we look at the numerical example, we're basically seeing how many times 3 goes into just the first part, 17. Well, similarly, we're going to do the same thing here. We're going to see how many times x goes into 2x squared. In other words, what do we have to multiply x by in order to get 2x squared? So if I have x and I want to go to 2x squared, I'll have to multiply by a 2, and I also have to multiply by an x. X times 2x is going to give me the 2x squared. So once you figure out what needs to go on top here, now you're going to take this and multiply by both things on the outside. 2x times x is 2x squared. 2x times the 5 is going to give you 10x. Now, as long division, what we were doing up here is notice that we had a minus sign. We're also going to subtract here as well. So 2x squared minus 2x squared is nothing, it's 0. 3 minus 10 is negative 7x. Last time, we brought down the 8 when we were doing long division. So this time, you're going to bring down the minus 35. Now we're going to ask ourselves, what do I have to multiply x by in order to get negative 7x? And the answer will just be negative 7. You'll take negative 7, multiply it by both things on the outside, and we'll put that in our notes. Negative 7 times x is negative 7x. Negative 7 times the 5 is negative 35. We subtract this again, and because we have exactly the same thing on top and we're subtracting itself away, we get a remainder of 0. So in this case, the quotient is going to be 2x minus 7, and the remainder is going to be 0. Now on the homework, they're going to ask this a couple different ways when you do something like this. First of all, you might see quotient remainder, and I might ask a question like that, but there's also other ones that will just have answer equals, and then just be a big blank on the bottom. So if you want to write this out, then basically what you can say is all this up here is equal to, what you're going to do is you're just going to take and write all this out. So it's going to be 2x minus 7. Now normally we put a plus, and then you put the remainder over the thing that you're dividing by. You don't have to do that here because our remainder is 0, so you don't even need to put this part in the end. But I'm going to show you that because other problems, there might be some other remainder besides a 0, and you might actually have a number up on top of here. So if you have a problem in the homework that just has a big blank and doesn't have it separated with quotient remainder, then you want to write it out this way. What you do is you just take the quotient and you put a plus sign, and you just put the remainder over your divisor, the thing on the outside here. So 0 divided by x plus 5. Okay, so a couple different ways that you can write that answer. Now, one thing that's important to keep in mind when you're doing these kind of problems, when you do long division, you have to make sure that all of the powers are accounted for. And you want to write these always in order from highest to lowest power. So for instance, you've got a square, a power of 1, and then this would be like x to the 0 that you would have there. Now for something like this next example, what we're going to do instead is we're going to write it. Notice that there is a power missing. The square power is gone. So I'm going to put a 0 placekeeper in there instead. Okay, so I'm going to take all this and then divide this by x plus 1. Okay, so notice again, I added in the placekeeper. Now, the reason why we're using a placekeeper is because if you don't have a placekeeper, then sometimes we may end up subtracting the wrong thing. We don't have everything all lined up, and we might take a cube and try and subtract a square and do all kinds of wrong math on that. So that's why instead we're going to put a placekeeper in here, and that's going to allow us to be more organized when we write all this out. Okay, so we didn't have to do that on the previous example because all the powers were accounted for there, but on this one we do need to do that. So let's write this out. We're going to do the x plus 1 needs to go on the inside, and I'm going to do 3x cubed plus the 0x squared plus x plus 5. So whenever we have a power missing, we always need to put a placekeeper in for that one. And now we'll just run through the the steps for the long division. We have to ask, so another way of thinking about this, now before I mentioned, what do I have to multiply x by in order to get 3x cubed? Now, another way you could do that is that you actually just take 3x cubed and divide it by x. Just take the first term divided by the x on the outside. And if we do that, that's what we just did before in those beginning problems. And you get 3x squared, and that's going to tell you the thing that you're going to put on top there. Okay, so that's another way of doing it. You can just take the first term and just divide it by the first term here. And that's a way that you can do that. So that's how we got that first one right there. Okay, we multiply this by both things on the outside, so 3x squared, 3x cubed, sorry, 3x cubed, and then plus 3x squared. Notice that because I put the zero placekeeper in here, now I'm subtracting the correct thing. I have 3x cubed minus itself is 0. 0x cubed minus 3 is negative 3x squared. And I have plus x. So just bring down, we can only bring down just the next term only. Now we're going to take negative 3x squared and divide it by x. So if you take the negative 3x squared divided by x, you're going to get negative 3x. Multiply this by both things on the outside, negative 3x squared minus 3x. You subtract those. Now be careful here. To get this answer, we have to take a 1 minus negative 3. So if I do 1 minus a negative 3, I'm going to get a 4, just working with the coefficients. So that's actually going to be a 4x. So 1 minus negative 3 is a 4x. So be careful. That's another place where people make the most mistakes, is subtracting wrong with that. If I take 4x divided by x, I just get a 4. Okay, so I multiply that, I get 4x plus 4. If I subtract it, I get a remainder of 1. So for this, the quotient is going to be 3x squared minus 3x plus 4. And then the remainder is 1. So I could either have something like that where you write it out separately, or if they give you a big answer blank to write your whole thing out, then you would just write 3x squared plus, or minus, I should say, 3x squared minus 3x plus 4, and you just put 1, the remainder, over the divisor, which is x plus 1. Okay, so that's the other way that you'd be able to write this out. So quotient, remainder separately, or you just write the whole thing out in the blank. So either one they could ask you. All right. Do another one of these where we have to put in some placekeepers. All right, now this one, before I jump into the long division, I'm actually going to rewrite this. I have to do this with highest to lowest power. If there's any terms missing, I want to put in a placekeeper for that. So this, I'm going to do 3x cubed first, and I have minus x squared. I have plus x, and then I have minus 2. All the powers are accounted for here. I have 3, 2, 1, 0. So now it's written from highest to lowest power. I'm going to divide this by, now this one, there is a placekeeper that's missing in the middle. So I have a square, but I don't have an x term. So notice I'm putting in a placekeeper for that. So this is the way we want to start by writing that out. So I'm going to put x squared plus 0x minus 2. I want to divide all this by 3x cubed minus x squared plus x minus 2, just like that. 3x cubed divided by x squared. I'm just going to get a 3x out of that. Whatever you put up here, when you multiply it with the first term, you should always get the first term that's inside the division bar. So 3x times x squared gives you the 3x cubed to be expected. 3x times the 0x is going to be a 0x squared. 3x times negative 2 is a minus 6x. Again, we're subtracting this. So the cubes are going to drop out. I have negative x squared minus nothing, so I'd still get negative x squared here. Now, careful with this. I have 1 minus a negative 6. So 1 minus a negative 6 is like 1 plus 6. So I get 7x. And then I'm going to subtract the minus 2. If I take negative x squared divided by x squared, I get negative 1. So I'll take negative 1 times everything on the outside. I get negative x squared. Negative 1 times nothing is just going to be a 0x. Negative 1 times 2 is a plus 2. Then we subtract all this. 7 minus nothing is going to be 7x right there. And then we want to do the remaining part on there. And so we get a, for this, this is a plus 2 here, not a minus 2. I just realized this is plus 2, not minus 2 on the outside. Okay, so I got to change this. Sorry about that. Apologize. Wrote the wrong thing down here. So this is going to be a plus 6 here, which means that when you do this part here, this is going to be a 5x. So because we have a 1 minus 6, so I have a negative 5x. So I'm going to erase this part and put a negative 5x instead. So negative 5x. Okay, and so this is going to be on the bottom here, this is going to be a negative 5x. Negative 5 minus nothing is negative 5x right here. And this is now this is going to be so now with this, when I multiply, this is going to be a minus 2 here, which means that these 2's will cancel and you just get negative 5x as your answer. So apologies for that. This is a plus 2, it should have been, and so now we fixed everything to make it correct. So negative 5x is now the remainder. Okay, so we have quotient is 3x minus 1. Remainder is negative 5x. And then if we have this in the answer blank where we write everything all out, we have 3x minus 1. Now, because the remainder is negative here, you can just go ahead and put a minus and put 5x over x squared plus 2. So we can just do that. If it's negative already, you don't need to put the plus sign, you just put a minus there. So quotient, we have a minus sign, and we have our 5x over x squared plus 2. So that is now going to be your correct answer. Okay, so we have this here divided by using another one where we have to put some place keepers in for that. So for this, we want to rewrite this. So this part up here, I want to write that as 3x to the 4th power. I'm missing a cube, so I'm going to put a 0x cubed in there. In fact, the square is missing also, so I'm going to put a 0x squared there. Then I have minus 2x minus 1. So I want to put these in here with these place keepers. So when I write this inside the division bar, I got x plus 1 on the outside, and I have all this that we'll put on the inside here. So we put these 0 place keepers in there, just like that. And now we're ready to go through the long division steps. Negative 3x to the 4th divided by x is negative 3x cubed. Multiply this by both things on the outside, we get negative 3x to the 4th plus 3x cubed. And we just need to subtract these. So if we subtract that, that's going to be nothing. 0 minus 3 is negative 3x cubed. So again, as you see there, because we're putting the place keepers, we're ensuring that we're subtracting the correct powers. So all the 3's are lined up, and we get that, negative 3x cubed. Okay, and then we just bring down the next one. We bring down 0x squared. Negative 3x cubed divided by x is negative 3x squared now. We multiply that, we get negative 3x squared plus 3x squared like this. And we subtract again, and we get negative 3x squared. and we bring down the minus 2x. Negative 3x squared divided by x is negative 3x here. If you multiply that on each side, you get negative 3x squared, and then we get plus 3x when you multiply negative 3x times negative 1. Subtract again, we get a 0. Okay, so now we get something different. We have negative 2 minus 3, that's going to be negative 5x, and then we're going to bring down the minus 1. Negative 5x divided by x is negative 5. We get negative 5x plus 5, and then if you subtract that, negative 1 minus 5, we get negative 6 down below. Okay, so for this one, by going through all that, you get I'll just write out the whole answer. What we'll have here, negative 3x cubed minus 3x squared minus 3x minus 5. We have minus 6 over x minus 1. So I'm just going to write out the whole thing. Otherwise, the quotient would be the part you see on top there. Remainder is negative 6. So this would be the entire answer if they want you to type it all out. It'd be all this with the minus sign because the remainder is negative. And then we have the remainder over the divisor x minus 1. All right, so now we have a kind of a you try it problem, one you can do for practice, but we'll just go ahead and do this one together here. So 3x minus 5 goes outside. Now this we don't need to put any place keepers in because all the powers are already accounted for here. So for that, x minus 14. Okay, so now we can just jump right into the long division. So 9x cubed divided by 3x, we get a 3x squared here. Multiply by both things on the outside, we get 9x cubed minus 15x squared. You're doing subtraction with this. Be careful, you have negative 6 minus a negative 15, so it's negative 6 plus 15. So we get 9x squared, and we'll bring down the next thing. 9x squared divided by 3x is going to be positive 3x. 3x times everything on the outside there, you get 9x squared minus 15x. Again, we have a negative 6, and we're subtracting a negative 15, so we're going to get a 9x here. We bring down the 14. 9x divided by 3x is just a 3 this time, plus 3. 3 times everything out there, you get 9x minus 15. Okay, so now we're subtracting all this here. So you have negative 14 minus negative 15, so we just get a remainder of 1. So this would be 3x squared plus 3x plus 3 plus 1 over 3x minus 5. And that would be your answer with the long division. Okay, so now we have one more here. You guys can just try that problem on your own. For the sake of time, I want to go on just to do the synthetic division. We've seen enough examples of these, but you can try that one on your own. Okay, so this one, well, actually, you know what? Let me go ahead. I'll still do this one because it has a place keeper. So I just want to make sure you guys understand the place keeper. So let's go ahead and we'll still do this one. Notice that this one does not have a square in it. So we have to put a 0 place keeper in. There's no square, but everything else is there as is. So you want to write all this out like this first. So that's how you want to set it up. 4, 3, 2, 1, 0. Now all the powers are accounted for, and we can just jump directly into the long division steps now that we have the place keeper in there. So we'll write all this out inside here, and we'll do the long division. 3x to the 4th divided by x is going to be 3x cubed. Multiply both things, so 3x cubed plus 21x cubed there, and then you're going to subtract. We have 18 minus 21 is negative 3x cubed. Now we bring down the 0 placekeeper. Negative 3x cubed divided by x is negative 3x squared. Multiply this by both things on the outside, negative 3x cubed minus 21x squared. Now be careful when you're subtracting this. We have 0 minus a negative 21. So you're going to get positive 21. So 0 minus a negative is positive 21x squared. Bring down the minus 3x. 21x squared divided by x is going to be plus 21. Okay, so plus 21 we get there. 21 times both things on the outside there is 21x squared. And then we have the 21 times 7. So 21 times 7 is going to give you 147. Okay, so this is going to be 140, positive 147. So we put that right here. It's going to be the, so 1 second here. Yeah, so plus 147 we get this. Okay, so 1 second, I had to look up something over here. I want to look at one of these problems to see how that was done. Okay, so so again, by doing that sort of thing here, we're doing let's see, so 21x. I'm sorry, this should have been 21x. That's why I'm getting tripped up on this. Yeah, we lost the x here. There we go. Now we have it correct. Okay, yeah, so 21x it should have been, because 21x squared divided by x is 21x, not just 21. These should be descending powers, by the way, when you do these. If you don't have descending powers, you want to go back and double check that. So we have descending powers now, and so now we're ready to subtract this. So this case, you're taking negative 3 and you're subtracting 147. So you're going to get a 150x here. And then we bring down the 40 on that. 150x divided by x is plus 150. So now we take this times both things on the outside. 150 times x is going to be a 150x. And then you have a 150 times 7, and that's going to give you 1050. 1050 right here. And then you subtract that there. And so when you subtract that one, you're going to get negative 1010 as the remainder there. So you're going to have 3x cubed minus 3x squared plus 21x plus 150 minus 1010 over x plus 7. And so that's now going to be the answer on that one going through. So the main thing is, don't forget to put the placekeeper in. That's the most important thing when you have that. Now this can get kind of long. Obviously here you're trying to figure out all the x's, and we got a little stumped or stopped here by the x. We forgot to put the x on there, and that threw us for a little loop there. But there's a better way of doing these. It's something that's called synthetic division. Now, synthetic division can only be done for cases where we're dividing something by a 1x to the first power. So like this last problem that we just did here, this you tried problem, we could have definitely used synthetic division on that. And synthetic division involves not using any of the x's at all. So sometimes it's a little bit easier for us to use. Now, unfortunately, it only works for a 1 in front of the x and x raised to the first power. So if you're dividing by like a 3x plus 7, for instance, you can't use synthetic division. And if you're dividing it by like x squared or something like that, then you can't use synthetic division either. Okay, so let's go ahead and jump through how you would do synthetic division. Now, synthetic, the way it works here is you're going to write everything all out, just the coefficients only with no variables. So the first thing you want to do is whatever is inside the parentheses, you're going to take the opposite sign. So instead of +2, we're going to put -2. And what you do is you put it in a little box, like a half box like this. So it was a +2, we make it -2. Then you're going to put the coefficients. Now, again, you want to make sure that these are descending powers. If there's any terms missing, you do want to put a 0 placekeeper in for that as well. But in this case, you don't have to worry about that because all the powers are accounted for. So I'm going to put a 1 there, minus 7. Come on, pen. Minus 7, minus 13, and then 15, like that. And then we have a line that goes underneath. And you're going to leave a little space underneath because we're going to be getting some numbers that are going to go in here that we're going to be adding together. What you do once it's set up like that, so again, you put the opposite sign of that in a little half box like this. You write out the coefficients of the first part, and then you just drop a line down and leave a space. So now let's go through and run through the synthetic division steps. The first thing you're going to do is whatever number is first, you're automatically going to drop that down. That's it. So that's all you have to do, just drop that number down. Next, you're going to multiply the number down below by the number in the box, and you'll put that result in the next column. 1 times -2 is -2, and that's going to go in the next column. Now with synthetic division, your adding is the operation. So long division is subtraction, but you're adding when it comes to when the synthetic division. Add that together, you get -9. Now you're going to take -9 times -2, it's 18, and we write that down in the next column. Okay, -9 times -2 is 18. We add it together, you get a 5 here. Okay, 5 times -2 is -10. We're going to add this together, and we get a 5. Now this part, this number on the end, this is automatically your remainder. This part is going to become the quotient. Now originally we had x cubed, and you're dividing it by an x, which means that this is going to be a 1x squared. This is going to be a -9x, and then plus 5. So this part here is going to be your quotient. If you want to write out your answer all at once, like that, if it doesn't ask you for quotient remainder separately, then you can write it out this way. Okay, so x squared minus 9x plus 5, and you can just put plus 5 over x plus 2. And that's going to get you exactly the same answer as if you go through it by long division. So it's a lot easier because we don't have any variables that we have to deal with here. There's less to write out too when you have something like that. So let's do another one of these. Okay, so again, this number right here, we want to take opposite sign. All right, so instead of a -3, we're going to put a +3 inside the box. Now for this one, before we put this into the long division, let's rewrite this. We want to put this in order from highest to lowest power. So I have x to the 4th minus 2x cubed plus 3x squared minus 4. You must make sure that you put it in order from highest to lowest power. And also what I noticed here too, before I put the -4, notice there's no x term. So I also need a placekeeper in this problem as well. So I have 4, 3, 2, 1, 0. So I had to do two things. I had to rearrange it from highest to lowest power, and I had to put a 0 placekeeper. Now the 0 placekeeper does actually appear when you write out your coefficients. So I have a 1, x to the 4th, I have a -2, I have a 3, I have a 0 placekeeper, and a -4. So this is even more important to have a 0 placekeeper, because if you don't have the 0 placekeeper in there, then you're not going to get the right remainder or quotient. So it's very important to put that placekeeper in there and to have it in order from highest to lowest power. Now we'll go through the synthetic division steps. 1 drops down automatically. 1 times 3 is 3. 3, we're adding that together. 3 plus -2 is a 1. 3 times 1 is 3. Now I get a 6. 6 times 3, 18. Add that together, we get 18 here. Okay, so kind of just keep on going again with that. And then the last column, no matter what, is always going to be your remainder. So we'll do, this is going to be the 54, and so we get a remainder of 50 here. Okay, it's remainder of 50. Okay, so we have, if I want to write out the quotient, I'm just going to put, so originally I had x to the fourth. Every time I do synthetic division, it's going to take your power down by 1. This is now going to be x cubed. So I have x cubed plus x squared plus 6x plus 18. And then my remainder is going to be a 50. Okay, so I have quotient and I have remainder on that one. Or again, if I wanted to write all that out, I could do x cubed plus x squared plus 6x plus 18, and I can put plus 50 over x minus 3. Okay, so that would be your having it written all the way out. Okay, so next one. All right, so this, again, we have it with descending powers, but the problem is we don't have x to the fourth, so we do need to put a placekeeper in for that. We have 6x cubed, but we don't have the x squared term, minus 14x. Now we also need to put a plus 0 in here as well. Now it's very important to put a plus 0 on the end. It may not seem like that makes a big difference, but actually it does, because if you don't have that plus 0, then when you do your synthetic division, you may not have that column in order for you to find the remainder. Okay, so that's why it's important to put that in there. We're going to take the opposite sign of -2 becomes +2. Then we have 2, a 0, -6, a 0, -14, and a 0 on the end as well. Okay, so we just have all the coefficients in for that one. Go through the synthetic division steps. 2 drops down. 2 times 2 is 4. We're doing adding whenever we have synthetic division. Add that together, we get a 4. 4 times 2, 8. Add that together. 8 plus -6 is 2. 2 times 2 is 4. Add that together, we get a 4. 2 times 4 is 8. -14 plus an 8 is -6. -6 times 2, -12. Add that together and you get -12. So again, this number on the end is the 12 here, -12. That is going to become that's your remainder. Okay, so let me make that look more clear here. There we go, -12. Okay, so that's your remainder. And it just depends again on how they want you to write that out, how they want you to write it. If they want you to do that, let's write it out all in one line here. We have 2x to the fourth. It was a fifth power, but synthetic brings your power down by 1. 2x to the fourth plus 4x cubed plus 2x squared plus 4x. And then we have -6. So we have all this 4, 3, 2, 1. No, this is descending powers like you should be getting. Because the remainder is negative, I'll just put a minus there, and I'll put 12 over x minus 2. Okay, so that would be the whole thing. Otherwise, you've got all this stuff up front is your quotient. The remainder is -12, if it asks for that. So we got a couple more. They're just some you try it problems. So we'll kind of finish off this section with those. So let's do these two. All right, so this one, I have a 3, I have a 2, I have a 1, I have a 0. There is nothing missing here, no placekeepers needed. So I'll just put -2 in the box. I have a 5, 4, 3, and a 1. That's just the different coefficients from my original one. Again, no placekeepers needed on this example. Drop down the 5, and we're just going to do multiply and put that in the next column. 5 times -2 is -10. We're going to add that together. -10 plus 4 is -6. -6 times -2 is +12. We're going to add that together. We get 15. 15 times -2 is -30. Okay, -30 plus 1 is 29 is your remainder. So I have 5x squared, because it was a cube originally, minus 6x plus 15. X plus 15. I have minus 29 over x plus 2. That would be your answer for that one. And then we have a last one here for you, try it problem. This one, we have a 4, a 3, a 2. We're missing the x term, so we have to do 9x to the 4th plus 10x cubed plus 7x squared plus 0x. We need a 0 placekeeper in there, minus 6. Okay, so we have to put the placekeeper in this one. That's a minus 1, so we want to put a positive 1 inside the box. We have minus 9, a 10, a 7, 0, negative 6. And we have a space for the numbers here. Drop down the minus 9. Negative 9 times 1 is negative 9 here. You're adding with synthetic. 10 plus a negative 9 is a 1. 1 times 1 is a 1. Add that together, we get an 8. 8 times 1 is 8, goes in underneath the next column. Add it together. 0 plus 8 is 8. 8 times 1 is 8. 8 plus negative 6 is 2. Okay, so going through all that, we'll just write this out again. This number is, circle number is the remainder here. That's the 2. So I have negative 9. It was a 4th power, so it's going to become a 3rd. And all the other powers just kind of descend down from there. So plus x squared plus, that's going to be plus 8x. So 3, 2, 1 plus 8, like that. Then we have plus 2 over x minus 1. And then that would be the whole thing that you write out. So we have all the descending powers plus the remainder part on the end on that. Okay, so that's everything from the CR16. And so that's the homework. This goes up to CR16 for this week. But we'll go ahead and start on 4.6, and we'll just do a little bit of this. So that way we don't have to do as much on Tuesday when we come back. Because we have to finish 4.6 and 4.7 by Tuesday. So if we start 4.6 today, that'll give us a little bit, we'll be a little bit ahead there. So this is for next week's material now. So 4.6, it's called the real zeros of polynomial functions. There's a couple things up front here that you can read first, and we'll jump into this example problem. That's going to kind of make things a little bit more clear. Okay, so this one I wrote out for you ahead of time. Actually, you know what? I have my wrong notes up here. Let me go back to this. I need to open up the guided notes. I had my written notes up there instead. So let's go ahead and jump into this part here. So let's go ahead and open up the guided notes for the 4.6. So let's do that. Okay, so guided notes for 4.6. There we go. Okay, so now this is better. So it has a space for us to write. Okay, so the real zeros of polynomial functions. The first thing is we've got these two theorems that are here. And so I want to go ahead and use this example down below. That's going to talk about these. But the remainder theorem just says if you're dividing a polynomial by x minus c, then your remainder is the same thing as f of c. So we'll take a look at that a little bit later here. If the remainder is 0, that means that something divides in evenly and it's considered a factor. Okay, so that's what the factor theorem says. So I'm going to go ahead and show you how this property works by doing this example problem down below here. So let's assume that we don't know any of these properties. And if we don't know those, we're going to have to do this the long way. So first of all, we want to find f of 2. So if we don't know anything about these theorems, that means that if I want to find f of 2, that's done the old way by putting a 2 in here for the x's. So I would just go ahead and put in a 2 for all the x's like this. And so then I would just simplify each of these. 8 times 2, that's 16. This you get a 16 as well, plus 10, and then minus 3. So if I add all this together, what I end up getting is that f of 2 is equal to 7. So that's by doing it the old way. Now, next thing it says to do is use the remainder theorem to find the remainder when f of x is divided by x minus 2. Well, this is something that we can do by synthetic division. If I'm dividing it by x minus 2, I would take the opposite sign of that. So I would put a 2 inside the box. Then I have a 2, a minus 4, a 5, and a negative 3. And then I would just go ahead and go through the synthetic division step. So 2 drops down. 2 times 2 is 4. If I add this together, I get a 0. 0 times 2 is 0. If I add that together, I get a 5. 5 times 2 is 10. 10 minus 3 gives us a 7. Notice that the remainder that we got by using synthetic division, so basically the number we had in the parentheses was the same number we put inside the box here. So notice that I got exactly the same result. When I did synthetic, I got 7, but I also got 7 by doing it the long way. That's actually what the remainder theorem says to do. So if I get f of c, I can find it out the old way, but also I could find the value of f of 2 by using synthetic division and just finding out what the remainder is. So if I do synthetic division, the remainder is the same thing as if I were to just put 2 in and do it the long way. So that's what the remainder theorem actually says. Now it does say another question here. It says use the factor theorem to determine whether x minus 2 is a factor. Okay, so basically we're going to put x minus 2 is not a factor since the remainder was not 0. Okay, since the remainder was not 0. Okay, that's the factor theorem says that it's only a factor if you get a 0 when you do the remainder. So also 2 is not a 0. Okay, so 2 is not considered to be a 0 or x-intercept. That's also because I did not get a 0 for the remainder. So what it says here is that's basically what it says. So if x minus 2 was a factor, then I know 2 would be considered a 0 because I would get a 0 for the remainder. In other words, if I get f of 2 and I get 0, that means that x value of 2, I get a 0 on the graph. That would tell me it's an x-intercept. But I didn't get that in this case because I got a 7. So that's how that's what I know about this. I know for sure x minus 2 is not a factor since the remainder wasn't 0. And then I also know that 2 is not a 0 because of that same reason. Okay. Let's do another one that has to do with those remainder and factor theorems. Okay, so given that they want us to find the value of f of 5. So I'm going to do this again the old way, and I'll do it by also using the synthetic division. So if I want to find this the traditional way, I would just put -5 in for all the x's here. And I'm going to go through all this here. So I want to put that in by using the traditional method where I go ahead and do that. So the notes, I don't think I wrote all this out separately. So let me do that for you here. So this is going to be if I take -5 to the 4th is positive 625 times 2 is going to be a 1250 here. And then if I take the 5 to the 3rd power, it's -5 to the 3rd power, which means I'm going to get a -125. and then times 12 means I'm going to get a negative 1500. So I should get negative 1500 here. Next, I get negative 5 squared is 25, and 25 times 6 is going to give you 150. So I get a 150 here. This is plus 25, and then I get plus 75 right here. Now, if we add all that together here, so 150 plus 25. So if I do all this and add all that together, so I get 1250 plus 150 plus 25 plus 75. I add all the positive numbers together, I actually get 1500, and I get 1500 minus 1500, which is going to give us a 0. Okay, so doing that the traditional way, I get a 0 for that. Well, what that means is if I take the number inside the parentheses, negative 5, and I do the synthetic division, I should get a remainder of 0 this as well. So I don't need any place keepers. So I have 4, 3, 2, 1, 0. So I have a 2, 12, 6, negative 5, and 75. So if I go through all this, I drop down the 2, negative 2 there. 2 times negative 5 is negative 10. If I add that together, I get a 2. 2 times negative 5 again is going to be negative 10. Negative 10 plus 6 is negative 4. Multiply these and put it underneath the next column. I get positive 20. 20 minus 5 is 15. 15 times negative 5 is negative 75. And yes, I do get a remainder of 0. So again, that's basically shows how the remainder theorem works. If you do it the old way, and then you do the same number with synthetic division, the answer should be the same. Okay, so that's how that one works. Now, one thing I also know about that is since I got a remainder of 0, and I originally was dividing it by x plus 5, that means x plus 5 is a factor, since remainder equals 0. Okay, so x plus 5 is a factor since the remainder is equal to 0. And also, if it's a factor, that means I can take x plus 5 and set it equal to 0 and solve. That means that negative 5 is a 0. It's a 0 because when I have an x value of negative 5, I get a y value of 0. So that also tells me that that's an x-intercept. Okay, so that's how the factor theorem and remainder theorems both work together. Again, you have to get a 0 in order for it to be a factor. If it's anything other than a 0, it's not a factor. We're actually going to be using this idea a little bit later in the section, because the whole purpose of this section is to find out where the parabola crosses the x-axis. Now, the ones we did this before when we did graphing polynomials before, but the difference was in that section, everything was all factored for you. Now we're getting into some polynomials that are not factored, and that's why we have to use these techniques to figure out where it does cross. We can also use the zeros in order to actually factor polynomials, which is something we haven't done yet so far. For instance, this is actually how something like that's going to work. It's asking us how to solve this equation, 2x cubed minus 3x squared minus 11x plus 6 equals 0. So we have this, we're given the fact that negative 2 is, so we're told that negative 2 is an x-intercept, or it's a 0 of this. So if we know what one of the x-intercepts are, we can use that in order to find out what the other ones are without actually graphing this. Okay, so in this case, what I want to do is I'm going to take the negative 2 that was provided for us. I'm going to put it inside a box. Now, we're not taking the opposite sign here because we're not actually dividing by a polynomial like x plus or x minus something. Because it's just negative 2 that's given, I want to just figure out what the remainder of this actually is, or what the quotient's going to be once I take this through. So in this case, if they give you a number that's considered an x-intercept or a 0, just put that number in the box directly. You're not going to take the opposite sign here because you're not dividing by x minus or x plus something. That's the difference here. So put negative 2 in there. Now I don't have to worry about any place keepers. I have 3, 2, 1, 0. So I'm just going to put these in as is, just like that. And then I want to do synthetic division steps. Now we're told that this is a 0, which means I should get a 0 for my remainder. If I don't, I got to go back and check my work. Maybe there was did a typo or made a mistake. So 2 comes down. 2 times -2 is -4. We're adding this together. -3 plus -4 is -7. Multiply that by -2 and we get positive 14. 14 minus 11 is a 3. So 3 times -2 is -6. And there we go, as expected, we get a remainder of 0. Okay, so what this means is that the quotient part, let's write that out. That's going to be 2x squared minus 7x plus 3. Remember, synthetic always drops the power down by 1. So it was a cube, and now it's going to be a square. Because this part is considered to be a factor, we can now set this equal to 0 in order to find the remaining answers of this. So I'm going to factor this. This time I'm going to use the trial and error method because there's not a lot of factors of 2 or 3. So for 2x, I want a 2x and an x here. That gives us the 2x squared. And then I want to try a 1 and a 3. And so I have 2x squared, I get plus 6x plus 1x, does give me a 7. Now, if I make both of these a minus on here, that will allow me to get a -7. If I have -1 times -3, that's still going to give me a positive 3 when I multiply those. So this is the correct way of factoring that. The last thing we'll do is just take both of these and set them equal to 0, and that's going to allow me to get the other answers to solve this equation. Add 1 divided by 2, I'm going to get a 1/2. And if I add 3 to both sides, I get a plus 3 here. So these would be the other answers. So so if I want to solve this equation, basically the answer for this will be the original one they gave us, because that also satisfies this. -2, 1/2, and 3. So all 3 of those would be answers to this particular equation if I'm setting that equal to 0. So that's your answers on that. The last thing that we're going to take a look at before we go today is going to be the rational zeros theorem. Now this is the same thing I took from section 4.2. This is the polynomial. I got an x to the n. So remember the n is the highest power, and the a sub n is the number that comes in front of the x that has the highest power. We also have another variable here, a sub 0. That's just the number at the very end that's not attached to any of the x's. So it's just sitting there by itself. So what we're going to do here is up above, the problem that we just did before, they gave us one of the zeros to use, so we could use that to solve that equation. So now the other problems that they're giving us, they don't give us the starter one. So what we're going to do is we're going to come up with a list of possible places where the graph crosses the x-axis. Now notice it says the word rational. The word rational means that the place where it crosses the x-axis could either be a fraction or a whole number. So that's what the word rational means. So what we're doing is we're coming up with a list of possible places where the graph crosses the x-axis. Now we don't know which one exactly crosses unless we do some testing, and we'll do that next time. But today we're just going to come up with the list of zeros. So what we're going to do is we're just going to follow this formula. Factors of the last number over factors of the first number is how you're going to do that. So let's do that for this one. We want to list the possible real zeros of this. So this is going to be factors of 8 divided by factors of 3. Okay, so a factor is a number that divides evenly into each of these numbers. So for instance, numbers that divide evenly into 8 would be a 1, a 2, a 4, and an 8. Now, of course, there's different combinations for you to get 8. I could have -2 times -4, that gives me 8, or +2 and +4. So I need to consider the plus and minuses on these as well. So what I'll do is I'm just going to put a plus or minus in front of each of these factors I'm coming up with. And on the bottom, we just have plus or minus 1, plus or minus 3. Okay, so it's all the numbers that divide evenly into 8, all the numbers that divide evenly into 3. And I'm putting a plus or minus sign in front of those. Now, this is not a list. We have to write this out as one big list. Now, the way we do that is you take all the numbers on top divided by 1, then you take all the numbers on top divided by 3. So that's going to equal plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. All these divided by 1, you'll just get the same number you started with. But now we're going to take all these numbers and divide it by 3. So we get plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3. All the numbers on top divided by 1, you get the first 4. All the numbers on top divided by 3, you get these on the end. So this is going to be your list, and this is what you put for the answer. Some of these problems in my open math are going to be multiple choice, so you just choose the correct one like that. Now, if it's not multiple choice, unfortunately, if you put this in to my open math, there's no plus or minus here. So you'd have to put 1, -1, 2, -2, 4, -4, and so forth all the way across. There's not many problems where you have to write that out. If there is one like that, it won't be a big long list like this. It won't have as many factors to write out. But you would have to write those separately if it asks you to type those in individually. But a lot of these problems in there have a multiple choice feature with that. I want to do, so the rest of these here we'll do next time. So I want to go ahead and stop at this point. So we'll talk about how we actually use the rational zeros theorem next time when we actually find out, and we have to actually test. We'll be testing with synthetic division, which ones actually work and which ones will actually, so you'll be able to tell where the graph crosses the x-axis by testing these list of rational zeros that you have. But we'll do that for next week. And so we'll go ahead and stop at this point. Anybody have any questions out there before we end the meeting? Okay, so no questions. So I'll go ahead and end this meeting. Enjoy your holiday weekend, and I'll see you guys next week.